So, what is actually flowing through those pipes? We tend to think of it as just one thing, natural gas, but that's not even close to the truth. It starts its journey as this wild, unrefined mixture. The best way to think about it is like a secret recipe, one that's been cooking deep underground for millions of years. It's a blend of really valuable ingredients, some unwanted contaminants, and one particularly troublesome element that can cause a whole lot of chaos if you don't get it out. So here's how we're going to follow this recipe from start to finish. First, we'll see what this stuff looks like right out of the ground. Then we'll meet the family of valuable hydrocarbons. After that, we'll pinpoint the unwanted ingredients that create a recipe for disaster. And finally, we'll see how it all gets refined into the perfect blend that actually makes it to your home. Okay, let's start at the very beginning, the wellhead. The gas that comes roaring out of a reservoir isn't ready for prime time, not even close. It's a raw, chaotic, high-pressure mix of all kinds of gases and liquids. This raw gas is, well, a jumble, a total mess. You've got the energy-rich hydrocarbons we actually want, but it's also completely saturated with water vapor. And a lot of the time, it's got other non-hydrocarbon gases mixed in too. Now here's the kicker. As it travels from the intense pressure and heat of the reservoir up to the surface, everything changes. The pressure drops, the temperature plummets, and all these liquids and gases start separating, creating this unpredictable flow that has to be tamed. All right, now let's get to the good stuff. Buried inside that raw mix are the core ingredients of our recipe, a group of molecules called hydrocarbons. These are the guys that actually provide all the energy. And as you can see, methane is clearly the star of the show. It makes up at least 75% of the mix, sometimes way more. But don't sleep on these other hydrocarbons. Ethane, propane, and the butanes, they are all incredibly valuable, not just as fuel, but as the raw materials for countless other industries. So let's meet the family, one by one. First up is methane, CH4. That's one carbon and 4 hydrogen atoms. It's the simplest and lightest of the bunch. Then you've got ethane, C2H6, which is a super important building block for all kinds of plastics. Propane, C3H8, you probably know from your barbecue grill. And then the butanes and even heavier hydrocarbons get used for everything from lighter fluid to blending into gasoline. But of course, no raw recipe is ever perfect. Along with all those valuable hydrocarbons, the raw gas is packed with a list of unwanted ingredients that can cause some really serious problems down the line. This slide really lays it all out, the good versus the bad. On one side, you have the energy producers we want to keep. On the other side, you've got the troublemakers we absolutely have to get rid of. We're talking about water vapor, which is surprisingly nasty, plus acid gases like hydrogen sulfide and carbon dioxide, and then inert gases like nitrogen. So why exactly are these guys so bad? Well, water is probably the biggest headache because it can form these ice-like solids called hydrates that can literally plug up a pipeline. Hydrogen sulfide isn't just toxic, it's extremely corrosive. They call gas with H2S in it sour gas for a reason. Carbon dioxide is also corrosive when it gets wet, and just like nitrogen, it doesn't burn. It just takes up space, diluting the gas and lowering its energy value. And these aren't just minor annoyances either. If these unwanted ingredients aren't meticulously scrubbed out, they can create a literal recipe for disaster, threatening pipelines, equipment, and even people's safety. This quote from our source material really just nails it. We worry a lot about the acid gases, and for good reason, but it's the seemingly innocent water vapor that acts as the trigger for the biggest operational problems out there. So what in the world are these hydrates? Well, picture something that looks a lot like snow or ice. They're these solid, crystalline structures that form when water molecules create a kind of cage and then trap hydrocarbon molecules inside. The result is a solid plug that's about 90% water and 10% gas. And this is the part that will absolutely blow your mind. A single cubic foot of this solid hydrate, so a block about the size of a microwave, can hold up to 170 cubic feet of natural gas. It's an unbelievably dense way to store gas. But inside a pipeline, it is a ticking time bomb. When these hydrates form inside a pipeline, they basically act like a cork in a bottle. They can completely stop the flow of gas, causing the pressure behind the blockage to build and build to incredibly dangerous levels. And as if a massive high-pressure blockage wasn't scary enough, there's another major threat. Remember those acid gases, carbon dioxide and hydrogen sulfide? When they mix with that water vapor, they form corrosive acids that literally eat away at the steel pipelines from the inside out.
So, to avoid all this chaos, the blockages, the corrosion, the raw gas has to be processed. This is where engineers take that subterranean recipe and refine it into a perfect, safe blend. We call it sales gas or pipeline quality gas.
And that final recipe is incredibly strict. I mean, these are the contract specifications that pipelines demand. Just look at water vapor. It's limited to just a few pounds per million standard cubic feet of gas. That is like trying to find one specific drop of water in an entire swimming pool. Hydrogen sulfide is measured in fractions of a gram. Every single component is just so tightly controlled. Ultimately, all of this processing and all this purification really comes down to three key things: making sure the gas is safe to transport without forming those nasty hydrates, making sure it won't corrode the millions of miles of pipeline it travels through, and finally, guaranteeing that every cubic foot delivered to you provides a consistent and reliable amount of energy. It's really an amazing process of purification, right? Turning this chaotic mix from underground into a precise, reliable product. But it leaves us with a pretty fascinating question for the future. The easy-to-get gas is mostly gone. So as we explore for gas in deeper, harsher, and more challenging environments, you have to wonder, what new and unexpected ingredients will future recipes contain, and how will we learn to remove them?